I've got to hit this thing.
Hello.
We add up two functions. Somebody give me a guess for a point that's going to be on the function created when you add up these two. What do you think it means to add up the two functions? The intersection? So you're guessing, what does that intersection look like?
Right there.
1, 5?
Yeah. 1, 4, oh yeah.
1, 5? Yeah, that's one point we think is going to be in the add. What else do you think is going to be in the add? When you add up two functions, what do you think you're adding up?
Slopes.
They're intercepts, so what are the two intercepts?
6, 0.
Or 0, 6 and 0, 3, so that should be 0, comma 9, right? Okay, there's another point. Any other ideas? Or maybe that's enough. Because you figure when you add up two lines, you're going to get another one. Another line. So let's see if that worked. And we just highlight this to see if you went okay. Okay. So, Josh, there you pick one here. But what's wrong with this one?
I'm wrong.
What's wrong with that intersection?
It's...
Why is that on the, not in the addition, but Josh's is though? What happened when we looked at intercepts? This is the intersection and these are the intercepts, right? What do the intercepts have in common with this point B?
Are we talking about the y-intercept?
3, 6, 9. So what do they all have in common? What do all the points have in common?
Factors.
Okay, something else, something more obvious. You got real tricky on me there.
They're all on the y-axis.
They're on the y-axis, which means x equals 0. They're all the same 0. They're all the same x. So now let's go back to your point. What do these two have in common? The points of the intersection, what do they have in common?
1 point. 1 exact point.
Okay, that's where the two cross. But what do the coordinates have in common?
We have x is 1.
And y is?
5.
So what are you adding up? If you add up 0, 3 and 0, 6 to make 0, 9, what should you add up with these 2 points? They're both on the same, that point intersection is the same thing. Should I add up the x's or the y's to add up a function?
Y.
A y. So where should it go?
12. 0, 12.
No. Point A again.
0, 9.
0,
We already
9.
have a 0, 9.
No, yeah, we're at 0, 9.
No, but if you go up another one, it could be 0, 12, and then that's false.
It's going to keep the same x of 1. That's where they crossed.
Okay. 1, 9.
But what's going to be the y?
1, 12.
If this was 1, 5 on the blue and it's 1, 5 on the red, 1, 10.
Oh yeah. Why? Suck it, because it's 5.
That's inappropriate language, Claire.
Sorry.
Yeah. 1, 10, and then you're on the curve, right? Okay, so this we took a long time on, but this is the idea of what you're doing when you're adding, subtracting, multiplying functions. You're doing it to the y values. Keeping the same x value, doing the same thing to the y values. Okay, so now it should be better with the subtraction. Now we're going to turn off the addition.
Yeah, it's just like not in this.
Here's the subtraction. Y. Give me 1 point. Why does that subtraction work that way?
1,
Welcome.
0, 1. I know. Yeah.
Whatever the intercepts.
They shifted over 1, 2, 3.
Think about the y-intercepts.
It says -2.
Yeah, so if this is f of x minus g of x,
Oh, y.
it's the y coordinate 3 minus the 6, and you're down at -3.
Is it okay that you can't see the board in this very
You can
well?
come closer. You can stand here.
So should I not like get the people?
I
Or
don't
you
get
can,
what
you can move between the two.
Wait, I don't get my, like, what Maggie's position is. Like, why is she
She's
videotaping
taping
us?
you live,
This is the
so you
live
can see your
feed.
question more, okay? It's not a live feed, no.
Live
Okay.
feed to YouTube.
All right, now let's go on to, so that was subtraction. Now we're going to go to, what if we subtract the other way? This was f of x minus g of x created this.
Right.
What's going to happen if we do g of x minus f of x?
It'll look like that.
So you put it in coming down. What's the slope of this? Positive or negative?
It'll
Positive.
be a negative
A
slope.
negative slope. And what is f of x minus g of x compared to g of x minus f of x? What happens when you switch the subtraction around? What do you do?
Switching first point that you're subtracting.
Like the whole thing comes
Making it
negative.
The whole thing becomes negative. And what happens when you negatize a function on the outside of the functional notation?
It
It's
flips
flipped over
over
the
the
X.
Y-axis.
Over the
X.
x-axis.
Boom.
So let's see if this flips over the x-axis. It was definitely a flip over the x-axis, right?
That's not just a change in slope.
Wait, that isn't this the
It was a big
y-axis?
change in slope. No, this is the x-axis. And we just took this and flipped it over to the x-axis, okay? Because you did the composition, not the composition, the combination, the subtraction of functions in reverse order. So be careful how you subtract functions. Okay, we're gonna turn those off now. Now, what happens when you multiply two functions?
It's
Stretch it. Just kidding.
Will it stretch?
It'll stretch. Oh, sure.
Again, remember, what are you doing to the
shrink
y coordinates?
horizontally.
And stretch
No, no,
for.
that's stretching and shrinking a single function. This is now combinations of two functions, and we're about to multiply them together here.
It'll increase the slope.
Will it have the same slope?
One of the same.
No.
Let's just take a look. And I think it's going to freak you out.
Oh man.
What is it?
Two
Oh.
straight lines.
You're not-
Those are Three.
No, they're not straight.
If
They're
that's
curved.
straight, then to change your window.
Ooh.
Oh my gosh.
What happened?
It's
Parabola.
Oh my gosh.
The parabola, because what happens when you multiply two linear functions
Oh, you
together?
get an x squared.
The x squared. And notice the negative x squared is going to make it come down. Now tell me one of the other things. Where are the intercepts on the parabola? Where's the parabola across the x-axis?
0, 6, 0, and negative 1.5.
And where else? What else crosses there?
The lines.
The lines. That's why we like it in this factored form.
Oh, in the same
Because where the lines make 0, the product will make 0, right? How about the peak? Where's the peak?
Like
28.
It's not where these two cross.
2.25.
27.5. But how do you find out where this peaks?
The
New
maximum.
max.
It's at the maximum, you use max on your calculator. How about if you're just looking at this picture, what are two things that can help you figure it out?
2.25.
You can, like,
Estimation.
Where's the axis of symmetry about? Someone show me with your arms.
Like 2
Show me with your arms. Right around there. Okay, and where did that cut the x-axis?
2.25.
Oh, so do you plug that in?
Compared to what?
6 and 1.5.
They were both halfway between those two.
Oh.
So that's that other trick to quickly coming up with the x squared and the vertex. Okay, that's multiplying two functions. What about dividing them? Is there going to be a line?
No.
Anything funny going to happen?
You're dividing an x by.
Oh. It's
And you're
really-
dividing by x, and x is underneath.
So,
What happens at 6?
a school.
It can't be 6.
Absolutely. Nope.
No.
It can't be 6.
Whoa.
Sure enough, can't be 6.
Oh,
And that's
vertical
hyperbole.
asymptote.
Vertical asymptote. Okay? What if we just divide the other way, though? Same thing?
This is good on video.
What?
No, much different function if you divide the other way. All right? Now, another concept. Now, this is really different now. And this is the composition of two functions. N is f of g of x. That's when you put the output of one function in the other. And for a picture, we get another line again. This is very hard to see visually because you're not keeping the same x's for each. You're taking the output of one function as the input for the next. So unlike all these other ones where you could keep 2 points with the same x and just add, subtract, multiply, divide their y's, now the composition of functions is much different. So we're going to shift gears now and go back to our,
Zoom out. No.
Zoom in and zoom out. That's what it does.
now we're going to actually do this algebraically. So here goes. Algebraically, I'm going to do the first one, then I'm going to want volunteers on the next, okay? Algebraically, to add these two up, to do f plus g of x, which is also known as, I usually do this, f of x plus g of x. F of x plus g of x, I just replace the f of x with 2x plus 3, and the g of x with 6 minus x. And so I add up the x's and and add up the y's, or add up the constant terms, and I get x plus 9. And sure, if that was our graph before, x plus 9, the y-intercept was 9. So that's the combining two functions by addition. Okay? You got it?
Yeah.
All right. Volunteer. Go for it. Difference.
Woo!
Subtract these two.
I want the next one.
F of x minus g of x.
Sitting on a desk. Sorry, Holly, my butt's in my face now.
That's not supposed to be there.
That's okay. Can be fixed.
Okay. So we do.
We have like 4 minutes left, just FYI.
That's fine. This was 3 minus.
So that is.
Excellent use of the parentheses there.
Yeah. What are you doing?
Marco's like,
Minus 2. Or minus 3.
That's 3. There you go. Okay. We just do some surgical erasing here.
Yeah, thanks.
And we can take that out.
The circle.
Beautiful.
Okay.
Ellie, make that yay clear.
All right, next. Now we're going to multiply two functions. What does it do to f of x times g of x?
Oh.
Don't worry. Thank you.
You have to. Just don't. It has. Isn't the shape of an accent to this one? Okay.
Oh, we're doing fine. We've only gone 12 minutes so far. Yours is a little longer because you started before.
Yeah, ours is 12.
Are we gonna be able to watch this?
Yes. Not
You pumped to watch yourself here, Margot?
Yeah. Yeah. Thank God.
We all are.
easy.
We're all
Now
really excited.
I can use that with Mr. R and give you both attention. Okay? There you go. 9, 12, 2x squared plus 9x. All right, and then the dividing, which could be the trickiest. I'm just kidding. It's not the trickiest, people. Come on. Stop freaking out. F of x over g of x is 2x plus 3 over 6 minus x, and you're done. Okay?
Can't do anything?
But now you can see, well, when we start graphing it, we're going to have a whole section on graphing rational functions like this. As Ellie was saying, you got a problem at 6 there, because you have division by 0, and that was a vertical asymptote, right? But there's also a horizontal asymptote, which is going to be at 2 over negative 1. Okay, now to wrap up, composition of functions. This is perhaps the doozer amongst doozers. How do you do f of g of x?
Oh, I know.
Yes.
I'm going to do the first one, I'm going to volunteer for the next one. F of 6 minus x, we replace the g of x with 6 minus x,
So 2.
and now twice 6 minus x plus 3. Everything that was x before in f of x now becomes 6 minus x. And then you distribute 12 minus 2x plus 3, so you get 15 minus 2x. There's our f of g of x. Okay, so now you volunteer for.
We're back.
So that's g of 2x plus 3, which equals 6 minus. Oops.
What?
Wait, hold on. Okay, 6 minus 2x minus 3 equals minus 2x minus plus 3.
Minus 2x plus 3. That's
that right?
great. Okay, and what I'll do is I'll paste that diagram on here so we got pictures of everything we did here to check it. If there's any mistakes, I'll fix it. Okay? What do you say?
Sounds good.
Flange out!
Okay.
Oh, I didn't know what you said.
Stop the tape. Oh, you know what? I forgot to record that.
Flange out?
No, you recorded. That's fine.
No, look,
You
it's
can
Oh,
start.
it's recorded.
No, we'll do the
Oh, wait, I gotta go like this. Boom. And now I gotta save that in CPC
like that.
and
Say
save.
flange out.
Flange
Where's recording video?
Flange out.
Just make that one.
Say
Okay.
flange out.
Flange out.
Flange out.
Flange out.
Out!
Yeah, 7.
Yeah.
We
Flange
all
out.
said